Okay, so on our next example, we are going to find the value of x and y if L is parallel to M. So I am going to add in here these markings. Okay, so when I start to look at this, I see two variables. So I want to think of some various equations that would work to support our relationships with our theorems. So I see that if lines are parallel, I see that these two angles are congruent by corresponding angles, okay? So I know that 5x squared, I know that 5x squared is equal to 3y, but I can't really do anything with that because there's two variables. There's only one equation. I also know that these two are vertical angles, and vertical angles are congruent. So I also know that 5x squared is equal to 11x squared minus x minus 2. And I see there's only one variable, so I can solve this. So this is a quadratic. I need to either factor or do quadratic formula. So I am going to first start by moving the 5x squared over because I need it to be equal to 0. So I'm going to have 0 equals 6x squared minus x minus 2. Okay, so you can factor. And so I'm going to factor with the guess and check method. And so what I'm going to do, when I do that, I know that, okay, I'm going to end up having, when I factor, I've got the A value is bigger than 1. So when I guess and check, I need to account for the fact that the factors could be 1 and 6, or they could also be 2 times 3. Now I'm going to do everything in light of positive numbers, and then I'll fit my negatives in as I work. So I know to get a 2, there's only one way to get 2, and that's 1 times 2. So I'm going to start with this. I'm going to start with, maybe it's 2x times 3x, because that would give me 6x squared. And I'm going to leave a blank in the middle, and then maybe it's going to be 1 and 2. And so what I'm looking for when I do, think about when you multiply binomials together. The middle term here is when you add two things together. So if I go through and I check the product between these two and the product between these two, when I add or subtract those together, it will give me this middle term. So if I do 1 times 3x, I get 3x. If I do 2 times 2, I get 4x. So if I do 4 plus 3, I get 7, but I can do 4, I can subtract 4 and 3 and make it say negative 1. So if I made the 4 negative and the 3 positive, when I add those together, I get the negative 1 that I want. So I trace that back up to my problem. If I wanted the negative 4x, that came out of multiplying 2x times 2. If I wanted a positive 3, that came out of 1 times 3. So I could always check this when I go to multiply it back out. I could multiply it back out and I would get 6x squared minus 4x plus 3x minus 2. And so when you go to combine like terms in the middle, that gives me this value here. So that's why when I guess and check, I can just look at the two inner terms multiplied the two outer, because what I'm really doing is adding them together. Now, if I got lucky on the first try, it is correct. If not, I would have had to switch some numbers around. You are welcome to do any method you want. You can do the X method, you can split the middle, you can do whatever you want. But I'm going to proceed with this part. Okay, so I have this quadratic I need to solve, so we need to separately set these equal to 0. So 2x plus 1 equals 0. And then I've got 3x minus 2 equals 0. Okay, when I go to solve this, I'm going to subtract 1 from both sides to get negative 1, divide by 2. Okay. Add 2 to both sides on the second equation. Divide by 3 on both sides. All right, so I want to make sure if they both work or if I should throw one out. So if I come up to my picture up here, so if you kind of think through, if I plug in a negative 1/2 and I square it, I get a positive number. And when I multiply by 5, I get positive. Same thing here, when I plug in a -1/2, I'll get 1/4. And so then I want to double check that I will still get a positive number here, so that those two angles will stay positive. So both of these are correct. So I'm going to have a couple of answers here for this problem. So I have two different x values. I need to use those x values to find the values of y. So when I plug in, let's see, let's go back up to this equation here. Okay, there's a couple of ways to do this. So if I start with this equation, I can substitute in either x value. So I'm going to work with what do I get for y if I plug in, it's actually negative, if I plug in -1/2. So let's do the math. I'm going to do 5 times -1/2 squared equals 3y. Okay, and so let's go through that process and simplify it. So if I do -1/2 squared, I get 1/4. Okay, and for now, I'll just leave it in terms of a fraction, maybe convert to a decimal at the end. So 5 times 1/4 is 5/4. Okay, and then let's divide by 3, or you could multiply by the reciprocal. Either way, if I divide by 3 or multiply by the reciprocal, I get 5/12 for y. Now, if I convert 5/12 to a decimal, it's a repeating decimal, so I'm going to stick with this as my answer. Okay, so I have one solution up here, and I'm going to write it down at the top. If x equals -1/2, y equals 5/12. Okay, so that's one set of answers. Okay, let's check the other. So if x equals 2/3, so let's plug it back in. So if we've got 5 times 2/3 squared equals 3y. Okay, but 2/3 squared is going to be 4/9. And then if I do 5 times 4/9, you can think of it as 5/1. So that's going to be 20/9. Okay, and you can either multiply by the reciprocal or you can divide by 3. And so if I leave it in fractional form, I get 20 divided by 27. Now it's not a repeating decimal, and also it's not terminating. So I need to leave it as 20/27. So then my second answer, so when x is equal to 2/3, y is, what did we have, 20/27. So all of this is my solution. Okay, so it's a pretty complicated case of parallel lines, but it just gets you to think through your factoring and then your plugging in. Okay, let's do one more type of solving because I want you to see the algebra behind it. So I have, again, find x and y in the diagram. And if you look at the diagram, look at these red markings. That's my indication they're parallel. So now I can use all these various theorems and postulates to link things together. So I want to look for some corresponding angles maybe, or some alternate exterior angles, or alternate interior. So let's start with, if I start with 5x plus 5y, that's right here. And so I can link it together with 60 because those are corresponding angles. Okay, so the corresponding angles postulate says that they're equal. So I can say that 5x plus 5y is equal to 60. Okay, now let's look at this angle right here. And it has a connection with 55. And so if you look at it, this is your transversal. So it's alternating the transversal, but it's on the interior of those lines. So those are alternate interior angles, and the alternate interior angles theorem says they're equal. So I've got 5x plus 4y is now equal to 55. Okay, I'm going to have to use, these are a system of equations. I am going to have to use a method where I'm going to use the elimination method where I multiply through by something. So if you look right here, if I can make one of these 5's negative, then I can add them together and the x's eliminate. So I'm going to do that. I'm going to multiply through either equation, top or bottom. I'm going to multiply through, pick one of them by -1. Okay, so when I do that, so I'm just going to bring everything over here. So my top equation, I'm not modifying. My bottom equation, I'm going to multiply by -1, multiply by -1, multiply by -1. Now we can add these together. So that adds to 0. 5y minus 4y is just 1y. 60 minus 55 is 5. Okay, so now I can take that and I can substitute it in for either this y or this y. So I'll just go back to the top equation. So I can do 5x plus 5 times, we calculated y to be 5, equals 60. So that gives me 5x plus 25 equals 60. Take away 25 from both sides. So that would give me a 35. And then x equals 7. Okay, so we could leave it like this. Also, a lot of times in algebra, we would write them as an ordered pair. That would be fine too. Okay, so if you would take a look at the homework that's in Schoology. Actually, I'll leave this screen up here, and you can copy that down or pause the video at this point to get the assignment.